Hi everyone, this is lesson 4.7. This is the last lesson of unit 4. So on next week, on Monday and Tuesday, you're going to do reviews, and then on Wednesday you're going to take a test. So the purpose of this lesson is to take the lines of best fit you made from your calculator. So you are going to need your graphing calculator with you, and use those to make predictions, either from data that's within your known range of data or outside. And that would depend on if it's interpolation or extrapolation, which we will talk about in just a second. So just some review for vocabulary. The best fitting line is the line that most closely follows a linear or a trend, linear trend in data. Linear trend. And if you feel like you don't need to write down the review terms, that's fine. But if you do, then pause and write them down. The correlation coefficient is a value between -1 and 1 that measures how well the best fitting line fits data. Also, for the best fitting line, you also have linear regression, and then you have a linear model. Those also mean best fit line of best fit. And speaking of which, a linear regression is also known as the process of finding the best fitting line. To model a set of data, usually done using technology, aka your graphing calculator or Desmos. A new vocabulary that you'll need to write down is interpolation is using your best fitting equation to approximate a value within the range of known values. And extrapolation is using the best fitting equation to approximate a value outside the range of known values. So, for example, let's say we have some data that goes from 2010 to 2020. An example of interpolation, think inside, would be, say, to use your equation to estimate what it would be in 2013, because 2013 is in between 2010 and 2020. Extrapolation would be using it to determine something that happened before. So what if you wanted to predict what it would have been in 2008? No, that's not as reliable because your data is supposed to be just from 2010 to 2020. Something could have happened before 2010 that could have affected the data. And also, if we wanted to use it to predict something like 2025, sorry, I can't write, 2025, that's also not as reliable because as we all know, anything can happen in a year. So that's what interpolation and extrapolation are. You do need to make sure that you write those terms down. All right, so here's our first example. The table shows the total number of CD singles shipped in millions by manufacturers for several years during the period 1993 to 1997. Make a scatter plot of the data. Now, important that when you see 1993 in your calculator, you're not going to type in 1993. You're going to type in 0. And then 1995 would then be 2. 1996 would be 3. 1997 would be 4. Okay, so you don't have 1994 in this data. That's okay. All right, so let's do the scatter plot, the stat edit on our calculator. So we'll go to stat, edit, clear your list. So you should have already gotten a lot of practice with this from the video you watched yesterday or 2 days ago and the Elastic you did yesterday. All right, so we're going to type in 0, 2, 3, 4. And then over here, we're going to type in the other values, 7.8, 22, 43, and 67. Oh, what am I doing? I messed up here. I did not want to do this. All right, so if you want to just get rid of a single item, you just press delete. Delete, delete, delete. All right, let's try that again. 7.8, 22, 43, 67. All right, so after that, we want to make a scatter plot. So we would go to our window to set our window. Since we're going from 0 to 4, we might go -2, a little bit before, a little bit after. So how about -2 to 5? And then our y's go from 7.8 to 67. So I might just go 0 to 70. 0 for y min, 70 for y max. You guys are getting pretty good at understanding what this min and max terms are. And then maybe in increments of 2. That way there's not 70 tick marks on the y-axis. All right, so if you click on graph, you will see your data. Now this line, don't worry about that. That's just some random line I had in my y equals. As long as you see 4 points, then you're good. If not, go back to your list and check to make sure that you plugged everything in correctly. All right, so we did that. And then find an equation that models the number of CD singles shipped as a function of the number of years since 1993. So that's where we go to stat calc. So stat over to calc, option 4, and then down to calculate. Now remember, if it doesn't give you the R values, it's because you need to turn your diagnostics on. You should have already done that a couple of days ago, but if you're not seeing it, that's what that means, and maybe it just got deleted, or you just need to go back and do it again. All right, so let's write down our equation to 4 decimal places. So y equals 14.4514x plus 2.434, the 2 rounds up to 3. So there's our equation. Approximate the number of CD singles shipped in 1994. Is this an example of interpolation or extrapolation? So 1994, like we talked about, would be inside of the range of known data. That's when x is equal to 1. So that would be interpolation. So all we would need to do is plug in 1 in for x right here. So if you take your calculator and just plug in 1, so 14.4514 times 1 is just the same number. So I'm just going to do plus 2.4343, and we get 16.8854. The units would be million CDs shipped. Part D says use the equation to approximate the number of CD singles shipped in 1998 and 2000. Let's just do 1998. Is this an example of interpolation or extrapolation? So this would be extrapolation because you're predicting something that's after 1997. Okay, so here you'd plug in, that would be x is equal to 5. So here we're going to plug in 5. So you know what? I'm going to, instead of writing out this whole thing, here's a little trick. You can go up to it, have it highlighted, and press enter, and then you can edit it. So if you want to edit it, you'll have to use the insert button here. You can't just type in a number because then it'll let you get rid of the plus sign. So if the insert button is right here above the delete, you press second, insert, parentheses, 5. You want to multiply by 5, and then close parentheses. And then to get rid of the blinking, like if you're done, then you just arrow over. Okay, and then you can press enter. So 74, that just saves you some time for rewriting the whole equation. So 74.691 million CDs shipped. Alrighty, let's go on to our, well, actually, was there another example here? I think I did have another question at the bottom. In 1998, there were actually 56 million CDs shipped. In 2000, there were actually 34 million CDs shipped. In 2000, you can do the work if you want. That would be X is equal to 7. You would have gotten 103.5941. So we were pretty off, right? So 103 compared to just 35 million CDs. Describe the accuracy of the extrapolation made in part D. Well, it's not very accurate because you don't know what the trend was after 1997. And this is CDs shipped. So think about what was happening in 1998 to 2000 that would cause the number of CDs to be shipped. Personally, as I was growing up in that time, what was happening is that people were starting to listen to, streaming music. We were buying songs on the internet using LimeWire. I think that was the partially illegal version, but anyways, so we were using those things rather than buying whole CDs as much. So that's why. So you can't use your linear model for things outside of the range of known values extrapolation because different trends could exist after that. Number 2, the table shows the median floor area of a new single-family house in the U.S. during the period 1995 to 1999. Find an equation that models the floor area. Okay, so same thing, except we're just skipping the graphing part. So let's go to our stat edit. Let's go to our list. And the most important things, which I emphasized in class, were stat edit and stat calc. Those are where you're going to enter your list and get your equation. Those are the most important things. So stat edit. So if you write anything down, you're not taking very good notes, but if you write anything down, it's stat edit, stat calc. All right, so once again, we're going to write 0 for 1995. So 0, 1, 2, 3, 4. And then over here, we've got 1920, 1950, 1975, 2000, and 2028. All right, and then my numbers match up. So then we'll go to stat calc, option 4. And there we have our numbers. Let's write it down. So once again, I stayed around to 4 decimal places, but if it only goes to 1, then you just write that down. So y equals 26.6x plus 1921.4. And then predict the median floor area for a new single-family house in 2000 and 2003. We'll just do 2000 just to save some time. So 2000 would be when x equals 5. So we just plug in 5 into our equation. So 26.6 times 5 plus 1921.4. So that'd be 2054.4 square feet. And then in 2000, I'll just tell you what the answer would be. So it's just to save some time for you. If you did plug in 8, actually, it's not that hard because we already have our equation. So if you just scroll up, press enter, and then go in there and change the 5 to an 8. Sorry, 8. You get that. So 2134.2 feet squared. So which would you expect to be more accurate? Well, 2000, because it's closer to the value of, or the known range of data. It's closer to 1999. All right, number 3, the table shows the number of participants in U.S. softball during the period 1997 to 2001. Predict the year in which the number of U.S. softball participants reaches 1.2 million. So in order to do that, we're going to need an equation here. So we're going to go back to our stat edit. We're going to type in our equation. Now this would go from 1997 starts at 0, 1, 2, 3, 4. So I actually don't need to rewrite my list 1. Did I press clear? I gotta press enter. Okay. So I'm just gonna rewrite my list 2. So 1.44, 1.4, 1.411, 1.37, 1.355. All right, so there's our values, and then we go to stat calc. So really, once you start practicing these steps for finding the equation, it really is not that hard. It doesn't really take that long either. No longer than solving an equation would be. So we've got our equation is y equals negative 0.02x plus 1.4352. Now, be careful though, because this says to predict the year. So predict x in which the number of participants, the y, is equal to 1.2 million. So we're doing the opposite now. We're going to set the y equal to 1.2, and then we're going to solve for x. Okay, so solving for x, you would subtract over the 1.4352. All right, so we'll do 1.2 minus 1.4352. That should give us a negative number, but that's okay because the other side is also negative. Okay, then we'll divide both sides by negative 0.02. So if you just take this divided by negative 0.02, and you get 11.76. Okay, so that would be in the year between a year 11 and year 12. So let's count. What would that be? 1997, 98, 99, 2000, 2001, 2002, 3, 4, 5, 6, 7. So that'd be 2007. Well, let me make sure I did that right. No, I think I did not do that right because I counted 1997 as 1. It's supposed to be year 0. So this would actually be in 2008. Okay. And then we have one more little tidbit before we close out here. It's about the zeros of a function. So we're done with our calculator now. And we're just going to look at what the zeros of a function mean. And if I can... All right, so a zero of a function, whenever you see zeros, all that just means is your y-intercept. An x value for which your function equals 0 or y equals 0. I'm sorry, I mean your x-intercept. It's not your y-intercept, it's your x-intercept. So since y equals 0 along the x-axis, a 0 of a function is the x-intercept of the function's graph. So it's basically where it crosses the x-axis. Those are called your solutions. So if you're solving an equation, that's where it would have a solution. So if we took our equation y equals 2x minus 4, let's put it on the graph. So I'm sorry, I know I said we were done with your calculator, but we're going to do one more thing. We're going to do 2x minus 4, and then press zoom 6. So here, if you look on the x-axis, it crosses at 2. So the solution should be 2. So let's check it out. So to find a zero of a function, you set the function equal to 0. So we're going to do 0 equals 2x minus 4, add 4 to both sides, and then divide by 2. So we get 2 equals x. So x equals 2 is the solution to the equation, and that's where it crosses the x-axis. And function notation is the same way. You set the function equal to 0 and solve for x. So whenever you're finding the zeros of a function, you just set it equal to 0. So find the zeros of the function from example 3 and explain what they mean. So last thing here. So if we were to find the zeros of the function, we would set our equation equal to 0 and solve for x. That would mean that the number of participants is 0. So we'd be finding the year in which the number of participants is equal to 0. And actually, if you went about and solved it, you would get x equals 71.76, which would be the year 2068. So really, that's not realistic at all, and that's not a reliable prediction. So that's one of those things that you just can't do when you're working with a linear model. But that's what that would mean. If the year in which you had 0 participants, which in this case is not, you wouldn't care about that because you don't think that the participants would ever equal 0. All right, so that is all for this lesson. Tomorrow you'll get some more practice with these types of questions. Hope you guys have a great day.